All right, here we go. Last instructional video. Let's rock this. All right, so now we're gonna kind of look at some slightly more complicated probabilities and figure out which techniques we're gonna use. So we're gonna decide, are we doing, a permutation or a combination. Remember, permutations, order matters. All right, order matters, and then combinations, right? Does order does not matter. All right. So let's look at this first one. Student ID number consists of 4 digits selected from 10 possible digits from 0 to 9. Digits can't be repeated. All right, that's good. What is the probability that a student is randomly assigned the number 4312? All right. Now, this would be a much different problem, right? If it would be a much different problem if you could repeat the digits, right? You just kind of multiply it out and you'd be good to go, right? Now, you can't. So 0 to 9, right? So you've got what? You've got 10 choices, right? 10 possible digits. So for your first digit, right? Your first digit, I'll say first, you've got 10 choices. And for your second digit, because they can't be repeated, you now have 9 choices. So it's almost like you're pulling it out of the number out of the hat, and then once it's selected, it's no longer part of the equation, right? Your third digit, you've got 2 digits that have already been selected that are no longer on the offering, and then your fourth one, you're down to 7 digits left, right? And so this is what you get, right? Now the thing that we have to figure out is, do we got to divide by like the number of ways to choose for or not? Now the thing is, does order matter? All right. So order absolutely matters when you're talking about a student ID number, right? Yeah, because if you get a number, it makes a difference if you have 4312 as opposed to 3412 or 3214, or however many different ways you can take 4 and arrange it, right? So these these 4 numbers and arrange them. So what we want to do is we want to just kind of leave it like this. So we're going to take it and we're going to go 10 times 9 times 8 times 7. I usually like to try to do simple multiplying first before I move from there. So I'm going to do 10 times 7 and get 70, and then 9 times 8 is actually 72, right? And so if I break this into 70 times 70 plus 2, right, it gets a lot easier, right? You get 4,900 plus 140, which is 4005, right? So 5,040 method, right? 5,040. So this is how many different ways you can do it. Now we got to answer the question. The question says, what's the probability that a student is randomly assigned that? So it's one student, 1 out of 540. So the answer would be 1 540th. And then that I absolutely need a calculator for. So 1 divided by 5040 equals 0.000198. If you move this over, it would be approximately 0.02%. All right, so less than 200ths%, right? So there's a lot of different ways you can get that, and that's kind of the idea. All right, now, board of 15 city alderpersons decides to randomly select 3 members to be on a special task force. 3 members to be on a special task force. So to plan the city's next Pi Day celebration, Sam, Valencia, and Shane are all alderpersons. What's the probability that they are all chosen to be on the task force? So the question to ask yourself here before we start is order important? Doesn't matter what way we choose Sam, Valencia, and Shane. And hopefully you realize that it doesn't matter if Sam gets picked first and Shane gets picked next and Valencia, or it goes Sam, Valencia, Shane, or it goes Valencia, Sam. It doesn't matter. So the answer is no. No, it does not matter. So if it does not matter, then we will have that final division step, because this is a combination, right? This is not a permutation. This is a combination. This one up here was a permutation. right? This is a combination. All right. So you say for your first one, right? There's you want to select 1 out of 15 and you want it to be that. So there's 15 different options, right? 1 out of 15. The next one is you have now 14 choices, right? So 1 in 14 chance that you'll get one of the other two, and then 13, 1 in 13 for that. So you have 15 times 14 times 13. And then you say, okay, the order doesn't matter. So that's when you divide by the number of ways you can arrange those 3 that are selected. So it's 3 times 2 times 1. That's our fundamental counting principle, right? And so we can do some division here, right? 3 goes into 15 5 times. 2 goes into 14 7 times, and then the 1's just there. So you have 35 times 13, right? And then feeling kind of lazy, so I'm going to just use the calculator, and you get 455. So there. So this is, right? And so the probability of that is it's 1 out of 455 that all 3 of them are selected, because they're asking for one event, right? So it's not 3 over 455, it's 1. It's the event that Sam, Valencia, and Shane are all picked, right? So 1 divided by 455 is going to be kind of small. So, and sure enough, it is. So it's 0.0022, right? Which is approximately 0.2%, right? Let's move that over 2 spots. So I hope this is starting to kind of sink in a little bit with you guys. I know that for me, it's a little bit of a learning curve with this stuff, and I got to really think about it. So I totally get it if you're kind of like, right? But just try to reason through them. When you can draw things out, draw them out. Use any visual representation you can. There's tons of stuff like this on the internet too if you need to, call and check it. They even have permutation and combination calculators. So the big thing is just remembering that a permutation is a case in which order matters, and a combination is a case in which it does not matter and will require a division step at the end. So hope this is helpful. We will see you in the homework vids.